Able to see the screen? Can you able to see the screen?
Yes, sir.
Okay.
Yes, sir.
Yes. Okay. After long back, we are getting to the topic. I hope something you kept in your mind about the definition of lattice and other classifications of the lattices. Anyway, so now we can enter into the another model, that is freshly we are going to enter into that. Anyway, I hope you had sufficient time to take rest. So please refresh yourself. At the same time, you can just keep in touch with the definitions what you have discussed in the last of the previous model. Okay, so that it can be easily can get into the topic which we are going to discuss now. So first thing is actually this model title says like Boolean algebra. Okay, I'll say which one is important on this, which one can be expected to as a single 10 mark, that can be discussed later. In this class, just very basically we can enter into see the definition of Boolean algebra and then related one small concept. Okay, with that we can wind up this session. Okay, so before that, first before we enter into the Boolean algebra, first we need to recall the concept of lattice and then other certain classifications, so that it can be quite easy to get into the topic of Boolean algebra. Okay, anyone can try to say what is the definition of lattice? Can you remember that? You can just say the rough definition, not in a proper way. I'm not expecting the formal definition, what it is given exactly in the definition. You can just say your views about the definition of lattice. Whatever comes on your mind, you can just reflect it.
Sir, every two elements have GLB and LUB.
Very good, superb. So hats off. Okay, so here if suppose in your given poset you may have the set of elements in which if you take for every two elements you should have the GLB and then LUB. That means if you apply both the things, that also should belong to the same set. Okay, so in which case if it satisfies this means then the given set is called lattice. Okay. So also we have discussed some classifications of lattices like sublattice and then complementary lattice, distributive lattice. There are other some definitions of the classifications of the lattices. Okay, in which here it's very important to know one is lattice, another one is complementary lattice, one more is distributive lattice. Okay, first can you recall what is the definition of complementary lattice? Complementary lattice.
Every element has a
Very good, very good. Every element.
Has a complement.
Very good. That's it. So every element should have the complement. Already we are anyway. I have just taken the previous. Yeah. See here, this is the complement lattice definition. So in which every element has a complement. Okay. So here at the same time, you should not have the repetition in the complements. Like if suppose if one element is already played the role as the complement means it should not repeat the same for the another element. Okay, that is actually anyway that is not get into the deeper thing. Anyway, you can just keep in your mind every element should have the complement. Okay, that you can keep in your mind. Also, you can remember that distributive lattice. What is the definition of distributive lattice?
So you didn't teach it.
Sorry. Yes, we have already taught this. Can you the slide?
Yes, sir, it's visible.
Yes, already it was discussed in the last class as the last topic also. Okay, so here distributive lattice means in your set, in your lattice set, if you pick any three elements A comma B comma C belongs to that set means it has to satisfy two conditions. One condition is given with respect to star and then plus same. Here you are just replacing the positions of star and then plus respectively. That's it. So here, if you take that, you should get the answer LHS equal to RHS. If it satisfies this conditions means, then the given set is called distributive lattice. So also I have assigned this problem to you to check, show that it is not a distributive. Okay, so these are the topics we have discussed. So related to that, now we can enter into the another model, uh, that is definition of Boolean algebra. So here, if one set is Boolean algebra means it has to satisfy two conditions. First, it needs to be a lattice. Okay, if one set is Boolean algebra means primarily it needs to be a lattice. Also, furthermore, it has to be exactly complemented lattice. Also, it should be a distributive lattice. Okay, if it is so, then the given set is Boolean algebra. Okay, so here if one set is to be called like a Boolean algebra means it has to satisfy two conditions. One is it has to be a complementary lattice, one more is distributive lattice. If it satisfies two conditions, then the given set is called Boolean algebra. This is the definition of Boolean algebra. So usually they will be given one set, okay, they will be denoted some set. Also they can define some operation like a divisibility or whatever less than or equal to, some operations can be given to you, in which they can just simply ask the question, check whether is it Boolean algebra or not. Okay, first you are supposed to check it is a complementary lattice, or also you need to check if it is a distributive lattice. Means in both the cases, if it is true means, then you can strongly say the given set is Boolean algebra. Have you understood this definition, basic definition of Boolean algebra? Is it clear?
Yes, sir.
Okay, fine. So next, so these are the laws already you are discussed. So anyway, you can just recall that. So identity laws means usually a plus 0 will be, that means here what is 0 and then 1 represents? Can you remember
The
that?
lowest and the
GLB,
topmost.
LUB.
Very good. Very good. So the lowest member of the your with respect to the Hasse diagram, okay, in which Hasse diagram it will represent at the least last level, okay, that at the same time one will represent the greatest element, okay, that will be the topmost value of the given set with respect to the Hasse diagram. So you all guys can remember that anyway, fine. Okay, very good. So so these are the laws related to that operations GLB and then LUB. Already we have discussed, that is given as the summary. Okay, fine. Next. Okay, quickly we can complete it. So here already I have told you they will be given one set. Okay, for that set they can just simply ask you to check whether the given set is Boolean algebra or not. Means first your task is assigned there, you need to draw the Hasse diagram first. Okay, you need to draw the Hasse diagram and then you can apply the first you need to draw the Hasse diagram, then you can apply the properties of Boolean algebra. First one is you need to check whether it is a complemented or not. Also you need to check distributive property. If it is true on both the cases, then you can say the given set is Boolean algebra. Okay, these are the duties you are supposed to check if the given set is asks you to check whether it is a Boolean algebra or not. Okay, so now they can just simply ask another question. D20 is Boolean algebra or not? That is a question. Also, they are asked another question. Okay, first, I'll say the shortcut to determine this kind of devices problem. Anyway, first, let us understand what is D20. Can you just list out the set D20? List out the members of
1,
D20.
1,
4,
2,
5,
1,
10, 20,
2, 4,
4,
5,
10,
10 and
10.
20.
20.
That's Okay. Devices of 20 are 1, 2, 4, 5, 10, 20. So likewise, you can list out for the other things. First, let us determine. Actually, last time it was asked as a single 5-mark question. So anyway, it's very simple. Here, devices of 20 with respect to the operation divisibility. That's what they are given here. Anyway, so here, your task is assigned there. First, you need to construct the Hasse diagram. Then you are supposed to check the complementary lattice property and then distributive lattice property. Okay. So instead of that, get into that properties of complemented and then distributed, it's quite complicated process. For this set, this is quite easy. Okay. For this set, 646, there may be members of the set count will be increased when you compare with the D20. Okay, that time it's very difficult to draw the Hasse diagram, and then you need to check between the every pass, every triplets. So that's quite a complicated process. So instead of that, they have just simply they have provided one superb theorem. That theorem says they have observed all the devices and then they have determined that theorem. Okay, if you apply that theorem, it's quite easy process to say the answer. Okay, that theorem says like, this is the theorem, it is given in your book. So anyway, it's a very interesting theorem. See here, if Dn is a Boolean algebra, here Dn means devices of n. Here n represents whatever may be the number. Okay, in which if your n can be splitted, like n1 equal to p1 into p1 into p2 into up to k. I'll explain to you what try to say. Here P1, P2, P3 up to Pk, that is in general Pi's are distinct primes. Okay, if you are able to split that n with respect to the multiples of distinct primes means, then your devices of whatever may be the number is exactly Boolean algebra. Otherwise, if you are not able to split as a distinct primes means in a multiple times, so that time it will not satisfy the property of Boolean algebra. That's what they have generalized as a superb theorem. So anyway, let us check with the previous problem, previous what they have mentioned in the slides. Okay, so here just 20. Can you try to write this in a distinct primes? Distinct primes. Can you just list out? Here you need to mention only the prime numbers. Can you list out?
2,5.
No, sir.
2,5.
2,5. Then is it possible any other numbers?
No, sir.
No, sir.
No, sir.
So here it is not possible to split as a multiplication of distinct primes. So here certainly you can say the answer D20 is not a Boolean algebra. Okay, now 30. 30.
325.
2, 3,
3,
5.
2, 3, 5,
2.
2.
That's 30, right?
Okay, so is it possible? Is it
Yes,
a
sir.
Boolean algebra or not?
Yes.
It is, sir.
Yes, D30 is a Boolean algebra. Very good. Likewise, next D66.
3, 11, and 2.
3, 11, and 2. Very good, superb. So here D66 is
Boolean algebra.
Boolean algebra. Next 210. So likewise, you can check for the 210 and then 646. That's your work. Okay. So here, if the problem is asked like that, you can just represent your answer in two ways. One way is you can just list out the devices of the value what they are mentioned under the D value, and then you can construct the Hasse diagram. Then you can check the complementary lattice and the distributive lattice. After that, you can justify your answer whether it is a Boolean algebra or not. In other case, you need to mention the theorem. You need to mention the theorem statement properly. Okay, like what they have given in the next slide. So by the way, you can mention the theorem. After that, you can simply denote like by the theorem, D20 is not able to split as a distinct primes, hence it is not a Boolean algebra. Likewise, D30 is possible to split as a distinct primes like 3 into 5 into 2, hence D30 is a Boolean algebra. So you need to write your answers in this proper way. Okay, have you understood what I have told you on this? Is it clear? Okay, one time this question was asked as a 5-mark question for the, I think, inter semester. Yeah, I am not sure, but I forgot the slot also, A2 or A1. Okay, so for that set it was as a single 5-mark question. In the 10-mark, one question as the part of that. Okay, so this is the problem related to the basic concept of Boolean algebra, and then related devices problems. Okay, for that theorem only I have explained this problem. Is there any doubt up to this?